Hello everyone. Okay, now this is second part of uh, algebra. The Okay, now in this part we are going to talk about the addition and subtraction of algebra. In the first part, I talked to you about the basics of algebra, what are constant, what are variables. I do talked about I did actually I did talk about what are coefficient, what are base, and what are power. Okay, now adding on to this, let's move to the second part, and that is the addition and subtraction of algebraic terms. Okay, before I go to the addition and subtraction of algebraic terms, the things that we do need to know is what are coefficient, base, and power. Just a small revision. This is the coefficient. This is the this is as I said. This is the coefficient. This is the base, and this one is the power. Okay, if you remember this, now we can move easily to our addition and subtraction. Now we need to remember a very important rule, and that is in addition and subtraction of algebraic terms, the base and 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 power needs to be same. Okay, now what do I mean by this? Only the algebraic terms having the same base and having the same power can be added or subtracted. Others we cannot add or subtract in algebra. For example, let's say if I say x square plus 2x, we cannot do anything here. Why can't we do anything here? Because let's check here. What is the coefficient of x here? The coefficient is 1. If there is nothing, then there is 1. So the coefficient is 1. So we do not need to care about the coefficient. Now let's care about the base. So the base is x. Yes, the base is x here as well. What is the power? The power is 2, but the power is 1 here. If there is nothing, that means there is 1. So although we have the same base, but we do not have the same power. Since we do not have the same power, we cannot add this. Let's take another example. If it is x square plus a square. Now let's check. We do have the same power here. Here is also power 2. Here is also power 2. And what about the base? The base is x, but the base here is a. So the although the power matches, but the base do not match, so we cannot add these as well. Now let's look at example number 3, that is 3p square plus 4p square. In this case, the base is same. Both of them have the same base, that is p. The power is also same, that is 2 and 2, and coefficient is 3 and 4, but we do not need to care about the coefficient. All we need to care about is the base and the power. Yes, the base is same. Yes, the power is same. Since the base and power is same, so we can add these algebraic terms. That is 4 plus 3, that is 7p square, and we can write it like this. So it's going to be what? It's going to be 7p square. Now then, I have few examples out here, and we are going to solve this. That is going to make our things much more clearer. Let me erase this all. Okay, now let's move ahead, and just a second, I'm almost done with it. Yeah, now let's look at the example number 1. In this example number 1, the base is x, both of their base is x, and both of their power is also 1, so we can add this. So if there is nothing, the coefficient is 1, so 1 plus 1 is 2x. There you go. In this case, the base is same, y, power is also same, 2, so we have 5y square. In example number 3 as well, we have the same base and the same power, so we're gonna have 5a cube. In example number 4 also, we have the same base, m and m. Power is also same, 4 and 4, so 5 plus 2 is going to be 7m power 4. Now let's move down and try some different type of questions here. Okay, let's look at these examples. Okay, In this example, there are three different terms. One is 2x square, another is 3x, and then we have 4x square. Here we have x, the base is x, here is x, here it's x, here it's x. But here we have power 2, here we have power 1, and here we have power 2. So we can only add the same base and same power. That is, we can add 2x square with 4x square. When we add 2x square with 4x square, it's going to be 6x square, but we will still have this 3x left, and we are going to write it as it is. We cannot make any changes there. Okay, we can add only the stuff having the same base and the same power. Look at this example here also. Let's find out what we can add. Think for a while, which one has the same base and the same power? Obviously this 5a power 4 and 3a power 4. Both of them have the same base, that is a, and power 4. So we're going to have 8a power 4. And we still have 2b cube left, that is 2b3 is left, and it is as it is. Now, let's look at a different question out here. Let's look at this one. What can be done here? Here we have base x and x power 4. We have x cube, and here we have x square, and here we have 5. We do not have any common base and common power, so we cannot do anything. We need to write it as it is, that is 3x square plus 2x cube minus x square plus 5. We cannot do anything here. Okay, do not get confused. We can only add and subtract having same base and power. The same rule goes for subtraction. That is, you're going to understand that we're going to have a 7x here, we are going to have a 3y square in the second number. Let's talk about this. Which one has the same base and power? That is this one. This one has x cube and x cube, so 8 minus 4 is going to be 4x cube. And what's remaining? Remaining is minus 3x. So how did I come up with 4x cube? That is 8 minus 4 is 4. Now let's talk about this one. Which one has the same base and same power? This one and this one. So it is 10a square minus 2a square. So it's going to be 10 minus 2. It's going to be 8a square. And what is left? Minus 4b cube is left. Okay. Now similarly in subtraction, there's another thing that you need to know. In this difficult question is going to make it much clearer. Whenever we open the bracket, here we have subtraction. Whenever we open the bracket, the sign do change, that is 3x power 4, and this plus will convert into minus, because plus minus is minus. I'm also going to talk in detail about this in the multiplications of algebraic terms. So in this case also we do not have the same base and same power, so this cannot be subtracted. Now then, okay, now let's try and do some difficult questions. Now as you can see here, this thing looks so messed up. Now let's see what we can do out here in this equation. Let's see what we can do out here. Let me just erase it. Yeah, there you go. Yeah. Now if you look at here, we have different terms here. Now if I start adding this number one, how am I going to do is, we have 2x power 4. So I'm going to find out where do I have the another x power 4, x power 4 and x power 4. We have in this two case we have x power 4. So 2 plus 4, we are going to have what? We are going to have 6x power 4. Now we are done with this. So we have 3x cube. Now I have to find x cube. Here is x cube and here is x cube. Now we need to understand that 3 minus 2 is 1. So 3 minus 2 is 1. Why? Because we have a negative sign here, and hopefully you guys have a proper understanding of integers. So it's like plus 3 minus 2, we have 1. So I'm going to write plus 1 x cube. You may or may not write this one. It doesn't make a difference. It's the same thing. Now I have to look for a x square. Do I have x square here? Yes, I have x square here. We have minus 1 plus 7. Minus 1 plus 7 is plus 6. Again, the laws of integers. So we have 6x square, and then we have a 5x, that is x power 1. Do I have a x power 1 here? Yes, I have a x power 1 here, but it is minus x. So 5 minus 1, 5 minus 1 is 4. Therefore, I'm going to write 4x. And then what else is left? It's the 6 minus 3. I can't write here, so it's going to be like 6 minus 3 is plus 3. And there we go. We have the answer of this one, that is 6x power 4 plus 1x cube plus 6x square plus 4x plus 3. Okay, now I'm going to try another question. Just let's try another one. uh, let's look at something difficult. Let's look at number 7. Okay, now then, here we have different types of, here in this question we have a different type of variables. We have a and we have b. Now the thing that we need to keep in mind is both the power and both the base should be equal. All the base and all the power should be equal. If I'm trying number this one, that is a power 5 and b cube, now I have to find a power 5 and b cube. Where do I have a power 5 and b cube? We have b cube here, we have b cube here, but we cannot use this one. Why? Because we have a power 4, but we need a power 5. Both the base should be same and both the power should be same. That is, we have this one. That is a power 5 b power cube. A power 5 b power cube. Both the base and both the power are same. So 4 minus 6, we are going to have a negative 2, because 4 minus 6 is negative 2. A power 5, a power 5 b cube. Next one is a square b power 4. Where do I have a square b power 4? We have it here, a square b power 4. Minus 3 plus 1 is again minus 2. Minus 2 a power 2 b power 4. There we go. Now in next one we have a power 4 b cube. Do we have anything left? No, we don't have anything left, so we can write as it is, plus 2a power 4 b power 4. Now can we do anything here? We cannot do anything here after this, because we have a power 5 b cube, a square b. uh, that I think something got erased off here, and I think it's b power 4. Yeah, and 2 a power 4 b power 4. So all of them has the same, although all of them have a same base, but all the expression has the different power. So this is our final answer. Let me try this question number 10, and let me explain the last example to you. In this case, let's start with the first expression. We have a square b4. A square b4. Let's find another a square b4. We don't have a square b4. Do we have? Yes, yes, there we go. We have one. That is this one. So 6 plus 2, I can write it as 8 a square b4. Now this is 4 a cube b square. Do we have a cube b? There it is. A cube b square. That is 4 minus 3. 4 minus 3 is 1. That is 1 a cube b 4. Now let's look at another one. This one is also done. So a power 4b. A power 4b. There they are. Minus 5 plus 1 is minus 4. Minus 5 plus 1 is minus 4. A power 4 b. There we go. Do we have anything left? No, we are done with everything. And now everything in this answer has a different base. uh, no, all of them has the same base, that is A and B, but all of them have a different power, so we cannot do anything to this. Okay, so now the key rule during addition and subtraction that we need to keep in mind is the during addition and subtraction of algebraic terms, we need to have the same base and the same power. If anything is different, either the base, either the power, or the power, we cannot add these terms and addition cannot be done in this case. Now, uh, yeah, that's it for this video. See you in the next video where I'm going to teach you about the multiplication and division of algebraic terms. You can pause my video in different parts and try doing this addition and subtraction of these algebraic terms. If you have any question, just write it in the comment box. I will make sure to answer your question. Till then, take care. Bye bye.